Folks, welcome to this video. Welcome to this channel. Thank you very much for watching. I appreciate you. And maybe even more so, I appreciate the fact that science, astronomy has brought us together at this single point in time for you to be able to watch this video and me be able to speak to you. It is a privilege. Image Barnard star. Let's talk about Barnard star real quick. Well, if you know anything about astronomy or have been doing some self-study or even formally educated in the subject, you've heard of Barnard star. What makes it unique, it has very, very high proper motion. Now, all stars move, and many of them move very, very, very fast. The problem is they are so far away we can't detect that movement easily. It takes special instruments and long-term photography. Take a picture in 1950 and then compare that same star against the background in year 2000. Maybe you'll see some movement. An analogy would be a race car, 250 miles passing right in front of me, 10 feet away from right to left. That thing is going to sweep through many degrees within a second. It's going to go flying past me. But I take that same race car at 5,000 miles distance at the same speed, it's going to barely look like it's moving. It's going to hardly cut any degrees right to left as it's passing, quote unquote, passing in front of me. We call that line of sight rate. What is the rate at which? What's that angular sweep that my head or my eyes or my hand or my arm is sweeping through as I'm pointing at this object as it's passing? So Barnard star has a very high sweep rate, line of sight rate. Proper motion is the formal term used in the world of astronomy. And it's not that Barnard star is moving excessively fast compared to the other stars. I mean, it's moving along at 90 kilometers per second. But that's, I guess a typical average speed. But what makes Barnard star unique and gives it such high proper motion is that it's close. Proxima Centauri, Alpha Centauri, and Beta Centauri are the three stars making up Alpha Centauri star system. We're always learning 4.3 light years away. Alpha Centauri is the closest star to us other than the sun. But there's actually two other stars there. Remember, Alpha Centauri is a tertiary system of three stars orbiting around each other. So at any given time, one star may be closer than the other. But generally speaking, it's Alpha Centauri. That's the term we use. The next nearest star is Barnard star. In other words, in terms of stellar distances, it is very close, and that is why we can see its motion, high proper motion. It will cover about a quarter of a full moon, half of a full moon, which is about a quarter of a degree in a lifetime. Now, that may not sound like much, but it actually is when you talk about stellar distances, right? So that's Barnard star. That's what makes it unique. We'd be able to see this with the naked eye, except for one problem. Barnard star is a dead star. Remember, stars, they're born, they live, and they die. Depending upon the original mass of the star, that will determine how this star dies. Some will die as a neutron star. Some will die as a black hole. Some will explode in a supernova, leaving a remnant behind. That may very well be a pulsar, which is a rotating neutron star. Or it may end up just being an average star, shed its outer layers, and end up being a cold, cool red ember floating in space. And that's pretty much what Barnard star is. It is a red dwarf. So let's talk about real quick. I captured this thing like I would any other astrophotography photo. Took a series of pictures. I stacked them, cleaned them up a little bit, processed them in PixInsight, and then exported a JPEG. Now, I didn't know if I had Barnard star or not. I look in this image, and you can see it there in front of you. Barnard star is the star with the arrow in front of it. But when you look at this, if I didn't have that arrow, how would we know which of these is Barnard star? Well, we wouldn't. So I had to go and do a confirmation, if you will, which is the same process I use when I image asteroids, when I image Pluto, because I don't know if it's Pluto or some star. It's so distant, and you're certainly not going to see any of Pluto's moons to confirm. So let's take a look at how I confirmed that this indeed was Barnard star. All right, gang, to confirm that I had indeed captured Barnard star versus just some random star out there, I used this website here, Astrometrynet. Now, I have used this site before, actually on numerous occasions, but I use it every time I want to confirm that I've indeed captured what I set out to capture. For example, I have intentionally gone out and imaged some extremely dim asteroids, and I've used this site to verify it. Also, Pluto, right? When you look at Pluto, an image of Pluto, as an amateur astronomer, I don't know if it's Pluto or some star. Certainly, I'm not going to see any of its moons. So I've used this site before. So what you have to do is you have to take your image and you have to convert it to a JPEG. So that's what I've done right here. Actually, I got a couple versions. I got one with the little arrow on it that you've seen. And I've got one right here, Barnard star 2. And I have to upload that. It doesn't take TIFFs. I use TIFFs as my final output, but when I need to do something with that image, post it online or go to this website, I need to convert it to a JPEG. So let's go over here to upload, choose file. Now we're going to go to Barnard star. Where's my JPEG? Right there, and I'm going to upload it. So I chose the file. It's a file versus URL, and I'm going to hit upload. Now it's started the process here, and it will refresh this page every 10 seconds to let you know that, hey, I'm still working on it. I think that's awesome because I don't know if the server crashed. What are we waiting on? And look at this. Go to results. It's already popped up, but we haven't had success yet. There will be a green success word right here once the thing's done. So what is it doing? It took the image we just uploaded, and it searches for stars, much like your stacking program. And it's not looking for big, bright, fat stars that we can see easily in the image. It's looking for little bitty dim ones. It'll find a set of those, and it forms geometric patterns between those stars. Hexagons, pentagons, triangles, squares, etc. And it just forms those forms. Forms those geometric forms. It doesn't care about stars. Now it just has forms. Then it goes through its database and looks for similar forms. Remember, in the world of geometry and mathematics geometry, objects are similar if they have the same interior angles, right? We don't have to have, and I'm sure there's another definition out there somewhere. It's been about 30 years since I've taken that course. But the point is, that's what it's looking for. And guess what? We've got success already. It found it fast. It does what we call plate solving, and it went through and it found in the sky that this image is a part of. So let's go to results page. And you got all kinds of things you can go look at here. It'll show you the stars that it detected in my image versus the stars that it detected in its imagery. Here is the image we uploaded, and guess what? The thing is so accurate that it can tell me the names of some of the major stars in my imagery, which is, quite frankly, pretty cool. But I think it's slightly off here, and that's important because I wouldn't want you to upload your image and say, well, I don't see a star inside the circle like I do right here in these guys. So don't be discouraged. Keep pressing on with this process. And the reason why, they've identified this star not because there's a bright light right there that's obviously a star, but because mathematically that's where it should lie based on their image database, right? Based on their imagery. So knowing that, they know based on their database imagery and those similar geometric forms that, let's say, a triangle between HD 163697 and 163591 and Barnard star should be like so. So they placed a moniker here, a label where Barnard star is based on the math that was generated from their imagery years back when this was taken. Whenever that was, obviously it was sometime in the past. And I find it interesting that there's a bright star here that isn't labeled, and it's red, by the way, because remember, Barnard star is a red dwarf. This isn't verification yet that we've captured Barnard star, but these are things I'm looking at when this pops up. But I love that these labels can come up here as well. And if I recall it, I'll also throw up NGC objects, Messier objects, Caldwell, other major things, galaxies, all kinds of stuff. There. So what I like to do is I scroll down here, and I always do the view in worldwide telescope. So let's click that. So this pops up, and okay, here's my hint of the day. And it'll go to that part of the sky that my image belongs to, and it will overlay my image. So hopefully you can see, and by the way, I can press the left mouse button down and drag around. Hopefully you can see their beautiful Hubble generated imagery or whatever it is that took these pictures. I always go to the DSS, which is what it defaults to, Digitized Sky Survey. In other words, this is color, what we'd see with the human eye, except for these dim stars, obviously. But what's cool is it overlays my image. And there's my image, and they've rotated it as required to match their imagery. So the first thing I'll do is I'll come in here and I pick just a couple prominent bright stars that are in my image. And then I come down here to this image crossfade. And when I slide this slider, it'll make my image go away. And I can pick any value, We can show my image completely or none at all. But what I'm looking for is kind of sliding back and forth and confirming that the bright stars in my image are also in their image. And obviously their positions relative to one another are correct. And that's really cool. And I've done this many times to confirm that I've indeed captured asteroids. And and sometimes I got to zoom in here close and really do. I mean, I'll watch a movie with my wife and sit here and do this for 2 hours trying to find that dadgum asteroid that should be moving. But look at this star right up here, by the way. Look how, based on their imagery and my imagery, it shifts a little bit, but all of my stars shift just a tad, it looks like, so there's nothing special about that one. But sometimes you'll find a high proper motion star just by virtue of the fact that you are hunting for asteroids. So let's go to that bright star that didn't have a label earlier, if you will recall, and it's right there. And in fact, it's big and bright and red. So what I'm going to do is turn my imagery on 100% and then look. It's not there. Now let's slide this over down here and slowly make my imagery go away and let theirs come up. And you can see it's in their imagery, but not in mine. In their imagery, but not in mine. I'm not sure what that blue, I mean, that's not a star. That would be an extremely bright star to be blue, right? Blue means hot and hot means bright. And blue also means young, generally speaking. So I think it's more of an optical effect by the fact that this is so bright, or maybe they processed it to make these dim stars show up, and yet ones that are close, remember Barnard stars close, have this weird anomaly. I don't know, it's kind of strange, but the point is it's in their imagery, but not in mine. Conversely, if we come up here, there's definitely a bright star in my imagery that's not in theirs. So I have confirmation now. I have, I don't believe in absolutes. So I'm not going to say I'm 100%, but I'm 99 point something or another percent sure that I have Barnard star. Why? Because remember in the previous page, it told me, remember the results page, I had the imagery that said Barnard star should be right here, but it slightly wasn't because of high proper motion. In fact, if we measured that, it's cool. Knowing the rate, the line of sight rate of Barnard star, I could take the date of that background imagery and my date of my imagery and calculate the number of degrees, maybe, or rather radians, or not parsecs, but milliradians. What's the word I'm trying to think of? Whatever, the parallax angle. I can't remember the unit measure parallax. But if we did the math, we'd probably find that what we see in those two different positions is indeed what should work out when we do the math behind it. And then I come over here, and sure enough, there's a star that's in their imagery that's not in mine, and a star that's in my imagery that's not in theirs. And it looks like we've got Barnard star. So that's how I did that. So we went to astrometry.net. I'm sorry, Astrometry, ASTROMETRY.net, uploaded our image, and we went to the Worldwide Telescope, and that's where we're at right here. And I love this site, by the way. And if there's anything nearby, as I zoom out, things that are very prominent or significant, it'll show up down here, and I can just hover over these, and the little circle, it's out of the field of view right now, there we go, will pop up. So NGC 69, there we go. NGC 6481, looks like it's some sort of cluster, is right there. Whatever the name of that star is, 66 Ophan Chia, whatever. It's pretty cool. And then my imagery right here. I'm sorry, they think Barnard. Oh, that's kind of cool. Let's do that. Let's zoom in where they think Barnard star is. Yep, well, it makes sense. It's where their image was. So, sure enough, they say that's Barnard star. But up in this window, by the way, this is everything I've uploaded. If I go here, there's a slight jump. Actually, just centered on not on my Barnard star, but on my image. But anyway, you guys get the drift, and so that's how we did. So that's how I confirmed that I've got Barnard star. It's also, again, the technique I use for asteroids, Pluto, and occasionally I'll just, if I didn't image what I intended to, I still save the nice, pretty processed image. I throw it up on this page, and I do that slider back and forth to see if maybe I've randomly caught something that's out there. Maybe I'll discover an asteroid one day using this technique. So, folks, I appreciate it. Thanks for watching. If you liked what you saw, hit subscribe. hit like, leave comments. I love answering questions and responding to comments, so leave those below, and I appreciate you watching. Thank you very much.